Have you ever stopped and wondered what an AI actually sees when it looks at a picture? I mean, we talk about computers recognizing things all the time, but what's really going on under the hood? Well, today, we're going to peel back the curtain. We're going to look inside the mind of a powerful AI to see how it learns to interpret our world, one tiny little pattern at a time. Let's dive in.
So let's just start with that big central question. When you or I look at a photo, we see a photo, right? Objects, people, a whole scene. But a computer, it starts with just a grid of numbers, just pixels. So how in the world does it get from that to knowing, hey, that's a cat or that's a car? The secret ingredient is something called a convolutional filter. Honestly, the best way to think of a convolutional filter is as a tiny specialized detective. Each one has one job and one job only, to scan an image and hunt for one specific, simple pattern. It could be a vertical line, a patch of green, maybe a diagonal edge. And the entire neural network is just an army of thousands of these little detectives, all laser-focused on finding their one specific clue.
Okay, but here's the thing. These filters are just numbers, right? They're code, buried deep inside a machine. So how can we actually see what they're looking for? It's not like we can just ask them. Well, it turns out there's a really clever technique to make these invisible filters reveal exactly what they're designed to find.
And for this little expedition, we're not just looking inside any random network. We're peering into a real heavyweight called VGG16. Now, this thing is a big deal. As the source material points out, it actually won the massive ImageNet competition way back in 2014. So yeah, we know this network is seriously good at seeing.
Now this process is just so cool. It's kind of like asking a filter, what do you want to see more than anything else in the world? We start with basically nothing, just a plain noisy gray image. Then we pick one single filter that we want to study. After that, we use an algorithm to tweak that noisy image, pixel by pixel, to make that one filter as active or excited as it can possibly get. The final image isn't something the AI found, it's the pattern the filter was literally dreaming of.
All right, so now that we know the trick, let's actually do it. Let's begin our journey into the network's mind, starting right at the very first layer, where all the raw image data comes pouring in.
And here they are. These are actual visualizations from some of the filters in the very first layer of VGG16. And as you can see, it's not looking for anything complicated. No faces, no wheels, no cats. It is starting with the absolute basics.
This just illustrates the starting point so perfectly. The first layer is all about learning the fundamental visual alphabet. It's building detectors for simple colors, for gradients, where light shifts to dark, and for simple edges, whether they're vertical, horizontal, or diagonal. These are the primitive building blocks for everything else that comes next.
Okay, so if that's the alphabet, what happens when the network starts forming words? Let's go a little deeper and see how this all starts to build up.
Now we're in the middle layers, and you can see right away how those simple edges and colors are being combined into something more. The filters here aren't looking for just a single line anymore. They're looking for combinations, for textures, repeating patterns, things that almost look like netting or scales or woven fabric.
And by the time we get all the way to the final convolutional layers, just look at these. The patterns have become incredibly rich and intricate. We're seeing complex combinations that are starting to look like parts of more sophisticated objects. Maybe the texture of an animal's fur or the pattern of a bird's feathers. The complexity has just scaled up dramatically.
But this brings us to a really, really important point, and it's a common misunderstanding. If the AI is so good at seeing objects, why aren't we actually seeing any of those objects in these pictures?
This is the key question, right? We know VGG16 can absolutely identify a dog in a photo. So why isn't there one filter that's just a perfect template of a dog's face? We've seen all these swirls and textures, but nothing that looks like a real-world object. So what's going on?
So here it is. This is the crucial point. The images we've been seeing are what the filters are dreaming of. We started with a blank canvas, and we created the perfect image to make each filter as happy as possible. What we are not seeing are little patches cut out from a real photo that the filter found. It's the difference between a filter's ultimate wish list and what it actually finds out there in the messy real world.
So, if it's not looking for whole objects, how does it all come together? The best way to think about it is that the AI is slowly and carefully building its very own visual vocabulary.
It's a whole hierarchy of understanding. In the early layers, it learns the letters of vision, those simple edges and colors we saw. In the middle layers, it combines those letters to form words, the more complex textures and patterns. Then, the final layers combine those words into sentences, recognizing that a specific combination of a fur texture, plus a circular eye pattern, plus a pointy ear shape, all of that adds up to the concept of a dog.
So let's make sure the main takeaway is crystal clear. A neural network doesn't see by matching an image to a giant library of photos it has memorized. Instead, it sees through a deep, layered understanding of patterns, building everything from the simplest line all the way up to a complex concept.
Peeking inside the mind of an AI like this it's just fascinating, isn't it? It shows us a completely alien yet powerfully effective way of interpreting the world. And it leaves us with a final, thought-provoking question. If this is the elegant, layered process an AI uses to learn how to see, what on earth will it learn to understand next?